Okay, the topic for today is quadratic functions. The very first thing that we are going to talk about today is the graph of a quadratic function. The graph of a quadratic function is a parabola, and that is the shape that you see right here in this box. And the parent function of a parabola is f of x equals x squared. So I know that one of the things you're going to have to do in your video is relate things to the parent function. And that is f of x equals x squared. Now if you go back up here to the top of the notes, the parabola is what this shape is called. It is the graph of a quadratic function, and a quadratic function, you need to know, is written in this form. F of x equals ax squared plus bx plus c. In the parent function, which is just x squared, the a is 1, and the b and the c are 0, so you just have the x squared. But all quadratic functions can be written in this form, where a, b, and c are just numbers. All right? And we're going to talk about all the different forms, because there are, just like with lines, different forms that you can write quadratic equations in, and you get different information depending on what form it's written in. All right, so let's go up here, and I want to point out right here, this is something called standard form. The vertex form of a quadratic equation is this. F of x equals a times x minus h quantity squared plus k. It'll take us a little bit of time yet before we do this, but one of the things that we are going to learn how to do is go back and forth between standard form and vertex form. It's easy to go from vertex to standard, and it is much more difficult to go from standard to vertex. But we're going to learn how to do both. All right? Okay. Some of the features of the graph. The axis of symmetry, just like we had for the absolute value functions, we have an axis of symmetry. All right, so in your graph, and you can barely see it here, but it's this dashed line right here. This is your axis of symmetry. And in this particular function, that line is the equation x equals 0. All right? Remember, the axis of symmetry means that on that line, both sides of the graph are mirror images of each other. So notice, the left side of this graph is a mirror image of the right-hand side of the graph. Now, the vertex of the parabola is HK. And remember HK? HK was the vertex of the absolute value function. Guess what? HK is the vertex of a parabola. And do you remember with the axis of symmetry, the equation for the axis of symmetry with an absolute value function was x equals h? Same thing with a parabola. And I think we're now beginning to understand that it's not just h, it's the equation x equals h. Okay, because I know that came up as an issue on that Chapter 2 test. So, the vertex of the parabola is this point right here. The vertex. All right, we need to get the shape of a parabola down, essentially. The shape of a parabola, because here's the thing, I don't want you to have to plot points every time you draw one of these. I want you to be able to use transformations, because I think that by now you have found that using those transformations is actually faster and easier than trying to plot points every single time you want to graph something. And that's what we're going to do, is use transformations. But before we can start transforming, you've got to know what the basic structure of the parent function looks like. So what I'm going to do is a table of values for the parent function, just for the parent function, and all other ones come from that basic structure. So I have some x values, and then I'm going to have y equals x squared, and this is our parent function. So I'm going to do -2, -1, 0, 1, and 2, and this is going to give us the basic shape of the parent function parabola y equals x squared. So x squared here is 4, x squared here is 1, 0, 1, and 4. So what you need to realize is the parent function has its vertex at 0, 0. It has a point at 1, 1 and at -1, 1. And if you notice, that's 1 up, 1 over, and 1 up, 1 over the other direction. Okay? Now, at 2 and -2, you're going to go up 4. So here's the deal. To go from this point to this point, you're going up 3 and over 1. From here, you're going up 3 and over 1 the next way. This is how the parent function graphs. And if you know the structure of the parent function, it'll be a little bit easier to do some of the others. So the very first thing that we're going to do is we're going to graph the function in the form f of x equals a x squared. So here's an example. And what do you think? Just let's think a minute. Based on what you know about a in transformations of absolute value and linear functions, what do you think a has to do with for quadratic functions?
Slope.
Well, it's like slope, but a parabola doesn't have a slope. What do we call that? What was it called? No, not slope.
Vertical
Translation. The compression.
Compression, and what's the other direction? Stretch. This is compression and stretch. So if you look at just the A greater than 1 is stretch, and if you have an A between 0 and 1, that is going to be a compression. So guess what? This is going to be compressed. It's going to be compressed vertically. So, whoops, I got to stand in front of here so we can all see me. Compressed vertically. So this ends up getting squashed down and it becomes wider. All right. Glad I'm wearing my Laker wear in the video today. Okay, it's all good. So here's what we know. This function is going to have the same basic shape. We don't have any vertical or horizontal translations. This is going to still have its vertex at 0, 0. But at this point, we haven't really learned a lot about the translations, so I'm going to do just a little bit of making a table. And you're going to notice that I'm going to do something specific here. And that is, I am not going to do both negative and positive points. And the reason why is I don't have any vertical or horizontal translations, so I know my vertex is at 0, 0. But if I can find the points on one side, the points on the other side are mirror images because I'm going to have an axis of symmetry like this. So axis of symmetry, and that is the line x equals 0. All right, I have a fraction, so if I'm doing points, it's nice to put in a 2 instead of a 1 because 2 divides by my denominator 2. So 1/2 times 2 squared, would you agree, equals 2? Okay? So I have the point 2, 2. And over here, I have the point -2, 2, because I have a mirror image point. All right, so when you look at these, like here, mirror image. And if I put in a 4, I have 1/2 times 4 squared, which is 16. Half of that is 8. So it's going to be way off of my particular chart. What if I did put a 1 in? What would I get as my y value? A half, because I would have 1 squared is 1 times 1/2 is a half. So it would be really right here, and there would be my mirror image. So what I want you to see is this. Do you remember how in my parent function it was up 1 over 1, up 1 over the other direction 1? With my a at 1/2, it's up a half over 1, up a half over the other direction 1. And do you see how here at this point it was up 4 over 2? All right, it's going to be half that, up 2 over 2. So here is my lovely parabola. All right. And let's turn the page. What I want to point out about this particular example here is that we have a negative in front of A. What do you think that negative in front of A has anything to do with? This is reflection over the x-axis. Yes. Okay, so again, I have no vertical or horizontal translation here, so there is my vertex. All right. Now, I know that my graph, instead of looking like a U, is going to look more like a hill because it's going to be reflected over the x-axis. If I want to get some exact points right now, I can plug some in. So we have 0, 0. That is my vertex. We'll put a little arrow here. There's my vertex. We'll even draw in the axis of symmetry. X equals 0. Okay. What if I put a 1 in? What am I going to get from my y value? Negative 1/3. So here's why. It's just so you can see that that very first point is going to go up a third, and then it's instead of going or down a third, instead of going up a third, and then it's going to go over 1. So it's right here, and then we can do a point like 3, which gets us something a little further away. And that would be negative 1/3 times 3 squared, which would be negative 3. So 3, negative 3. So there's a point. 3, negative 3. There's a point.
Wait, why did you do 3 again?
Because it's divisible by 3.
Okay.
Yeah. There we go. And I notice I only had to do the points on one side because the other points on the other side are mirror image points. So what I want to do is go to this box right here in the middle of the page and talk a little bit about some of the transformations, reflection, stretch, and compression. And we already have talked about these today. So here's reflection. You can see on the top, this is y equals x squared, and on the bottom, y equals negative x squared. It just flips it on the other side of the x-axis. Here is a stretch. It's where a is greater than 1. This particular example is y equals 2x squared. It makes it taller and skinnier. And then this one is compression. It is where a is between 0 and 1, such as here we have 1/2, and it compresses it vertically to make it wider. All right? So we're going to be looking for those in our particular graphs today. The next thing I want to talk about is horizontal and vertical translations. All right? So right here, if you had to guess, is this a horizontal or a vertical translation? This is vertical. Just like with the absolute value functions, a 5 subtracted at the end is a vertical translation. This is going to go down 5 units. So this is a vertical translation down 5. Now, because we know how y equals x squared is drawn, we know how this is going to be drawn. So if we move our vertex down 5 units, where do you think it lands? Right there. All right, so that's our vertex. And we still have the same axis of symmetry. Now remember the shape? The first point, up 1 over 1, up 1 over 1 the other direction. To get the next point, you either go up 3 and over 1, or from the vertex, up 4 and over 2, same place. Mirror image point over here. And we do it really, really quick, because we know these points are all this distance away from our basic parent function. We do not have to put these in a table and calculate them. This is fast graphing.
So how
All
did
right.
you know that the slope would be 1/3?
The slope is not 1/3.
Oh,
There is, first of all, it's a parabola. There is no slope.
the stretch. Compression.
There is no compression. There is no 1/3 here. I don't know where you're getting 1/3.
How'd you do it?
Because if you go back to the parent function, and remember we plotted the points, how far apart are all the points? All right? From the parent function, you knew to get to the first 2 points, that's 1 up, 1 over. From there, you either went up 1, up 3 and over 1, or from the vertex, up 4 and over 2. Either way, that's all you're doing. There is no compression.
So it's just gonna always be 1 up, 1 over?
Always, all the time. Unless you have stretch or compression. Okay, now, let me ask you, do you think this is probably horizontal or a vertical translation? This is written a little different. This is horizontal. This is a horizontal translation, and based on what you know from absolute value, what?
Right.
This is to the right. Yup, see? What you learned before, still useful. Okay, so our vertex was at the origin, but it's moving 4 to the right, so it's right here. So there is our vertex. And let's draw in our axis of symmetry. So the axis of symmetry is the equation x equals 4. And now remember how we draw? There's no stretch or compression, so same shape as the parent function. Up 1 over 1 first. Then go up 4 over 2. There's your same basic shape. No putting points in a table of values that's going to take you a while to calculate. There it is. Okay? Now, all the different translations that we have just learned about go into the vertex form of a quadratic function. Here is that vertex form. It is a times the quantity x minus h. The squared is outside of the parentheses and then plus k. The vertex is hk. And this is the same as it was with the absolute value functions. The axis of symmetry is the equation x equals h. Now, here's something to keep in mind. If a is greater than 0, which means a is positive, your graph is going to look like this. And what that is called is concave up. That's an actual term, concave up. If a is negative, and that's when you have a reflection on the x-axis, it's going to look like this, and this is what we call concave down. Okay, so you are going to see that terminology. So if it is reflected on the x-axis, it's concave down. If it is normal, it is concave up. So this one right here is normal. This is reflected on the x-axis. Okay? Just the concavity is terminology that you need to be aware of. So, for each equation, what are the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range? And we're going to find all of these things. All right. Would you agree that based on this, your H is here, your K is here, right? This is your A. Does that make sense? So your vertex is HK, which in this case equals what? 4, negative 2. Okay. What's your axis of symmetry? X equals 4. Okay, what's next? Now, let me ask you, based on the sign of A, is this shaped like a U or is it shaped like a hill?
U.
It is shaped like a U. So let me point out something to you. There is the vertex. In that graph, this is a minimum. In other words, it's the lowest point. If A is negative and you have what looks like a hill, here's your vertex. This is actually a maximum. So, given the sign of A here, this is shaped like a U. We won't have a maximum, we have a minimum. Agree? So, minimum point is 4, negative 2. All right. Now, next thing, domain. And for this, we could probably use, one of my little smiley face graphs. And I'm just going to, we're not going to have a lot of room for him, so let's stick him over there. Okay. our vertex on this thing is 4, -2, which is right about here. And this is quite skinny. I am not going to draw this perfectly because it takes too much time right now, but you know that because this is greater than 1, this is quite skinny, right? Okay, so it's going to look something like this. Would you agree that's reasonable? Okay, so you can see that this right here is a minimum. You don't have a maximum, you have a minimum. Now, the domain of a parabola or any function is the x values. So let's put a little arrow here. And we're going to also do the range, which is the y values. Would you agree, if I let this graph get large enough, this is going to go off in this direction infinitely? Fair enough? And it's going to go off in this direction infinitely. So it's going to go infinitely to the left on the x-axis and infinitely to the right on the x-axis, right? That means the x values that are part of this function are all the x values. So the domain for a parabola, any parabola, is all real numbers. Now the range is a little different. So if we go back to this graph, the range is the y values, right? And notice, down here we don't have any graph, right? There is no graph down here. But we've got graph up here, but not down here. Only from this point up do we have graph. What is the y value right here? -2. So here is our range for this particular graph. Our range is y is greater than or equal to -2. That's telling our reader where on the graph this parabola is. It goes from -2 infinitely upward. All right? So we've done all that. Now keep in mind, the domain, all parabolas, is always all real numbers. The range will not be. Okay. Let's proceed, because we're running out of time. To the next thing. We already did translations of parabolas. We talked about this in that last example that we just did. Let's go ahead and we're going to graph using vertex form here. So first thing, what is the vertex?
1, 3.
Yes. Okay, this is H, this is K. Let's draw that vertex. 1, 3. Now, that means our axis of symmetry is what?
1.
It's not 1, it's what? X
Oh.
equals 1. We don't want to lose that point on this particular test.
I lost it in the last one.
So now all of YouTube knows. All right. So this is x equals 1. There we go. Now, is this going to be shaped like a U or shaped like a hill?
Hill.
This is shaped like a hill because this is reflected on the x-axis. So, this is going to be shaped like a hill. This has a negative in front of A, which means it is reflected on the x-axis, which means flipped upside down. Now, look at what we have here. We're not going to be able to use our 1 up, 1 over business because we have an A value. Let me show you a really quick way to graph this. We already know our vertex. Let's get one other point. All right? If I put 0 in for x. Would you agree? Put a 0 here. And 0 minus 1 is -1. Square that. 1 times -2. -2 plus 3. There we go. So we've got 1. So 0, 1. And do you know what we call the point when we put x in for 0? This is from your linear equation video. What do we call it when we put 0 in for x? Has a name.
Y-intercept.
This is the y-intercept. Y-intercept. Now, do a mirror image point on the other side. There we go. Look at, we've got some shape to this. Okay, let's go to B. What transformations take y equals x squared into this function? What are they? Let's start listing them off. What about the plus 3? What does that do?
Shifting up 3.
Okay, vertically translate up 3. What about this?
Shift left 1.
This is shift left 1. Okay, what else do we have? What's this?
Vertical stretch of 2.
Vertical stretch of 2. And what's this?
Flip over the x-axis.
Flip over the x-axis. All right, there's all our transformation. One last thing to do, guys. We're going to write an equation for the parabola that we see here. All right? Okay, here's how we're going to do it. You know that we have y equals a x minus h quantity squared plus k. What are h and k? Okay, and would you agree they fall right here? So h equals 3, k equals 7. Now, here's what else we need to do. We've got to solve for what a is, and we don't know. We've got to solve for it. So we need one other point. So I'm looking around for one other point that's on here, and I feel like 9 and 4. So this is 9, 4. And the 9 is the x value, and the 4 is the y value. We're going to plug these guys and these guys so that the only variable we have left is a. That's it. So y is 4 equals a, x is 9, h is 3, and k is 7. And we've got to solve this for a. All right? So 4 equals, what's 9 minus 3? 6 squared is 36, so 36a plus 7, subtract 7 on both sides, and we have -3 equals 36a. Divide both sides by 36, and we have a equals -112. Now what we're going to do is write the equation, leaving the x and y right where they are, but we're going to put in the a and the h and the k, and we're going to have a perfect equation. So here's what we have. Y equals -112 x minus 3 quantity squared plus 7. So we put in the a, the h, and the k, and we have written an equation for a parabola from a graph.